Hello, for Data Communications and Network 1 class today. My name is Susana Tantulaves from Kasetsart University. Today I would like to talk about the topic protocol. What is a protocol? Protocol is a set of rules, that manage or govern the exchange of data. So you want to do data communications, communicate between the two entities in different systems. So you basically have two systems, and then you have like entities in here, and you want to communicate between them. So this is the protocol. Have to do this to make this possible, communication possible. Now, what is an entity? Entity is anything, that can send or receive information. Usually, it's application in your mobile phone or some email facilities in your mobile phone or your tablet or your computer. What is a system? A system is a physical object, that contain one or more entities. So if you have your mobile phone or your tablet that you have many applications, this is a system. So this is examples of the system. What are the key elements of a protocol? There are three things. The first thing is syntax. If you have written some computer programming, you will know that you will see many times, it show up as syntax errors. So if you write the format of the code is wrong, you forgot the semicolon or colon or something like that, it's gonna show up as syntax error. So it is involving the data format, and the signal levels like 5 volts or like 3.3 volts. What is the system that you are using? They have to match. The next thing is the semantics or control information. Control information is something that is not data. So if you have a frame that you are sending, these are the control information in the header. In control information in the header, and these are the data, that you are sending. So the control information will tell you how long the frame is or how long the packet is, what is the format that we are using, what is the code that we are using, something like that, to make the other understand the same thing. Like we using ASCII code, so that they will interpret it correctly. Or this is 1,000 byte long. Timing is about synchronization. Synchronization. So you want to know, the beginning of the frame, that the frame start here. So you have to do like, and also the correct start of the frame. The speed matching is like the data rate, that match. Sequencing is like the first packet is here, number 1. Second packet is number 2. Third packet is number 3. So you have to receive it in sequence, or you have to reassemble it correctly, reorder it, correctly. Now let's talk about protocol architecture. There are two main protocols that we are using nowadays. The first one is called TCP/IP, Transmission Control Protocol, and / Internet Protocol. There are two protocols that we are used in a protocol suite. They are used together. This is the most widely used one. This was developed before the OSI model. So it's the standard. OSI is the standard, but TCP/IP is something that everyone used, before OSI coming out. So now people use TCP/IP and not OSI. But we have to study OSI a little bit in order to know the conceptual design, that is modeled by the International Organization for Standardization, or ISO. OSI is abbreviated from the Open System Interconnection. This is a conceptual model, so no one uses it, but it's good to know how they divide the text in the communication system into layers. Now let's look at the concept of the protocol, or the layer architecture. The protocol architecture or the layer architecture. The concept is like black box, okay, or modular concept. Okay, so you have this is like number 1, number 2, number 3, okay, suppose number 4 here, number 5, number 6, okay. You can see that you divide the work, suppose 4, this is the total work, okay. You divide the work into smaller modules, okay, and each of them is a black box, okay. So number 3 and number 5, okay, is the black box of number 4. So number 4 can buy number 3 and buy number 5, okay, put them together in the number 4, okay. And number 3, okay, can be constructed by buying number 1 and number 2 together and put in together with the number 3, okay. And number 4 doesn't have to know what is inside number 3, okay. It can use its function, number 3 function directly, okay. So let's look at an example. I usually use the construction the PC, okay, unit, the personal computer unit, okay, as an example. So if you think of this, okay, you are the user, okay, so you buy keyboard and you buy monitor and then you buy the power supply, the main board, memory unit, okay, you buy the case, okay, and then you put them together, okay, and you get your PC. You don't have to know what is inside the keyboard, okay. You don't have to know what is inside the monitor, how is constructed, okay. And the main board, the one who sell the main board, okay, may use CPU unit, right? The CPU unit, okay, they buy CPU unit without having to build it, okay. And the CPU doesn't have to, the people who sell the CPU doesn't have to know how to make the PC, okay, just make the CPU. So everyone just work on their jobs description, okay, and without knowing what the others can, I mean, they don't have to know the details, okay, of how to build the others objects, okay, but they just know that keyboard can be used like this. If I put it in, I can input the information into the PC and show up in the monitor, okay. And by doing this, okay, using the black box and put them together like this, okay, you divide the text so that it's possible to focus on only the text at hand, okay. You don't have to know everything, okay. And this makes the communications, data communication, which is very complicated, make it possible to do and easier to do. Let's look at the OSI model. The TCP/IP we will focus in detail in another chapter, okay. So this is, we'll just look at OSI model quickly to see what is the conceptual model of the layer architecture, okay. This one, you have device A and you have device B, and they are connected through 2 nodes, okay. So you have like a network like this. So this is A, this is B, for example, and you have node, intermediate node in between, okay. So suppose this is node X, this is connected to node X, node Y, okay. You may have node C, okay. So these are the, let's see, okay. So these are the node. You may have another node here also. A is connected, okay. A is connected to the first node. The data from A, okay, will go from layer 7, application layer, down to the physical layer, which is layer 1, okay. Go down like this, and it will go to the intermediate node, okay, go up only to the network layer, because the network layer is the one who handle connection inside of the network, okay. And then since it's not the destination, okay, it will just go down to physical again, go up to the network layer for the next node, go down and then go up to the 7th layer, okay, at the destination. Okay, this is how you send through a network, okay. And in point of view, okay, of A and B, the application layer will just communicate with the application layer. The presentation communicate with presentation layer. It's going to be layer like this, okay. each layer is separate, okay? So you will just concern, this is my application, you use the same application, same email application to open it, okay? So application will just look at the other side application layer, but the actual transmission, okay? This one may help you a little bit more to understand how to go through from the seventh layer up down to the first layer, okay? So first you have data of the seventh layer, you put header in, you add header, okay, of this layer. Then you go down the whole thing, okay, go down as the data of the next layer. Then you add header again, okay. This header is contain the control information. You go down, okay, this one you add header and tailor at the data link layer. And then this is the physical layer, okay. This layer is this, cheap a little bit, okay. Go like this. Okay, so this is a physical layer. Physical layer will go through the physical medium, which may be the fiber optics, the wired air, okay. And then this is receive. Then you strip out, okay. You take out the header. You take the header out. You use the control information inside of the header, and then you take it out, and you leave the data, okay, to go to the next layer until you have the last data, this 7 here, go to the destination B, okay, which is the same data here, okay. So this is how you actually go through the layers and physical medium. This is comparison between OSI and TCP/IP. OSI has 7 layers here, okay. TCP has 4, sometimes 5 layers. This is, I got it from the Wikimedia Commons, okay. But in other places, sometimes the layer, they overlap, okay, because some functions of this layer maybe, I mean, they are not actually matched like this, okay. So this is just simple comparisons, okay. Transport layer is basically the same. This is content layer, this is called network layer. These 3 are considered like approximately application layers in the TCP/IP, okay. Data layer, physical layer is approximately network access layer. So TCP/IP, we will again look into the details later, but it have lower numbers of layers. What are the main functions of the layers, okay? Physical layer, we use medium, okay, air or fiber optics or wire, coaxial cables, okay, to transmit raw bits, okay, which is 0, 1 like this, okay. Not in frames or packet, not in a group of bits, just raw bits, okay. We have physical, electrical, procedurals, interface in terms of how many volts we are using, what is the procedure, send this first, something like that. Data link layer, okay. We group bits into frames, okay. We do error control and we do flow control so that the sender will not send faster than the receiver can receive, okay. So this is the data layer control error, okay, to reduce the number of errors to make it reliable communications at the other end. Network layer, this do routing because you have many intermediate nodes inside of the network, so you do the routing. You do congestion control to prevent the traffic jam or to recover, to ease the traffic jam inside of the network, okay. Transport layer, this one you do end-to-end reliable data transfer because maybe A and B have many network in between, so when you want to send, you want to make sure that transmission is reliable, okay, is correct, okay, no errors occur. These 4 are the layers that we will talk in this class for electrical engineering. The other 3, okay, they are basically like mostly focused by computer science people or computer engineering people, okay, but electrical engineering people will focus on the first 4. The last 3 presentation layer is like do encryption, for example, compression that we talked about before. Application layer, how to user interface, okay. Station layer is synchronization. So these 3 will not be talked about much in this class, and these are the reference. Thank you very much.